Okay, so let's go through these 9 questions, and we're going to start with question 1, of course. Let's see how we can break it down. So question 1 reads, given that 40 combined 4 is equals to 40 factorial divided by 4 factorial times b factorial, then we're supposed to find the value of b. So to start with, it's important to note that a factorial or a combination is given by this expression. So if you're combining n and r, for example, then it's going to be given as n factorial divided by n minus r factorial factorial. Now in this case, the n we're looking at is 40 and the r we're looking at is 4. So we're just going to do the substitutions and then we see how we can simplify. So where there's n, we'll put a 40, so that we have 40. Where there's r, we'll put 4, like that. So all this is equals to, again, there where there's n, we'll put 40 divided by 40 minus 4 factorial. R factorial is the same as 4 factorial, like that. So now that we have this expression, let's see how we can simplify this. So this whole part that we have here, we can say 40 combined 4, this is equals to 40 divided by, so it's important to note that, remember that this whole expression is equals to this. So we can say 40 minus 4, that is 36 factorial, 4 factorial. This has a factorial as well. So this is what we have. Now remember, this expression is also this expression is also this, meaning that this expression will be equals to this. So we can say 40 factorial divided by 4 factorial, 36 factorial is equals to 40 factorial divided by 4 factorial, 36, b factorial. I'm looking at this expression. So it's obvious that the value of b is 36, but how we do it is like this. We're going to say everything is the same except this part. So b factorial is equals to 36 factorial. So in short, b is equals to 36. And there you have it. That's your solution for this particular question. So how can we prove this identity? So we're going to take up the left-hand side, of course. So left-hand side. So the first thing we're going to need to do is we're going to say 1 plus, let's separate these two like this. So we'll say quot theta divided by tan theta. Like that. So the same thing. So this will be the same as 1 plus. Now we know that quot is the same as cos over sine. And tan is the same as sine over cos. Like that. So this will be 1 plus cos theta over sine. We reciprocate. This will be cos over sine. Like that. How does it proceed? 1 plus, so I'm multiplying everything in this case. So cos times cos, that will give us cos square theta, divided by sine times sine, that will give us sine square theta. Okay, so let's see how we can add these two, let's see how it will proceed. So we have 1 plus cos theta square theta over sine square theta. So the LCM in this case will be sine square theta. So 1 into cos sine square theta is sine square theta. Plus this into this is 1 times cos, so we have cos square theta. So now we know that identities, sine square theta plus cos square theta is just 1. So this will be equals to, this implies that we have 1 over sine square theta, which will just reduce to cos, or rather cosec square theta, because you know that 1 over sine is a cosec and 1 over cos is a sec. So there we have it, simple as that, hence shown. Expand 3 minus 2x to the power 5 as far as the term having x cubed. Okay, so first of all, we need to know the binomial formula theorem. So we can say if you want a specific term, we want to be using this one, which is n combined r, a, n minus r, b to the power r. So this is what we're going to be using for each specific term. So since we want the term as far as x power 3, then we'll need about 4 terms. Now understand this. A represents the first term, which is 3. B represents the second term, which is negative 2x. Then n represents the degree, which is 5 in this case, and r represents each particular term. So for the first term in this particular expansion, the first term we're going to combine 5 with a 0. So using the same formula here, we're going to say 5 combine 0, a, which is 3, then we have n minus r, so that is 5 minus 0, b, which is negative 2x, raised to the power r, our r in this case is 0. Okay, that's the first term. So the second term, so we can say plus 5 combine 1, 3 to the power 5 minus 1, negative 2x, raised to the power 1. Next, we'll combine 5 and 2, 3 to the power 5 minus 2, negative 2x, raised to the power 2. In the last one, we have 5 combine 3, 3 to the power 5 minus 3, negative 2x, raised to the power 3. So I'm going to end here simply because we've been told to expand as far as x power 3, and of course this will give us x power 3. So now that we've expanded up to this term, let's see how we can proceed from here. So if we combine 5 and 0, what we get is just 1. Then here we have 3 to the power 5. So 3 to the power 5 is simply 243. So this would be 1 multiplied by 243, like that. Then this is just a 1. Okay, plus 5 combine 1, that is 5. 3 to the power 4, that is 81. This will just give us a negative 2x, like that, plus 5 combine 2, that is 10. 3 to the power 3, that should give us 27. This will give us 4x squared. Okay, in the last part, 5 combine 3, that's 10. 3 squared, that is a 9. And lastly, 2 to the power 3 should give us negative 8x to the power 3. Okay, so let's rewrite everything now. So this part is just 243. This will give us a minus. So 5 by 81 by 2 should give us 810. So 810 x plus what we get here. So 27 by 10 by 4. This should give us 1080. So we have 1080 x raised to the power 2. Here what we get, remember these are in brackets. So that is 90 multiplied by 8, which should give us 720. So it's a minus 720 x to the power 3. So now we can see that we have expanded as far as x power 3. So this is how it's done. A circle whose center at 3, negative 5 has the equation x squared plus y squared minus 6x plus ay is equal to 15. Find the value of a and the radius of the circle. Okay. So first of all, it's important to note that Let me just rewrite the equation first so that you see what I'm saying. So the equation, just rewrite it. I have x squared plus y squared minus 6x plus ay minus 15 is equals to 0. So the 15 just goes to the other side. So the general form of the circle, if you want to find the center, it is given as x squared plus y squared plus 2gx. 2gx plus 2fy plus the constant, and this is equals to 0. Okay. So if you have it in this form, then it's important to note that your center is given as negative g, comma, negative f. Okay, so our job in this case is just to find the value of g and f. Then we can proceed and find the center. So to do that, we can clearly see that we can say the coefficient of x and the coefficient of y, we just pick them and equate them. So the coefficient of x here is 2g. The coefficient of x here is negative 6. Coefficient of x here is, or y, sorry, is 2f. The coefficient of y there is a. This simply means that the value of g is negative 3 and the value of f is a over 2. Okay. So now that we have that, remember that the center, we've been given the center already, which is up there. So the center has been given to us. Remember, center is written like this. So negative g, comma, negative f. But the center we've been given, which is 3, negative 5. So here where there's g, we're going to replace it with negative 3. Then where there's f, we're going to replace it with a over 2. So this is equals to 3, like that. So at this stage, it's obvious that this is equal to this 3 that we have here. So this 3 is equal to this 3, meaning that if you bring it here, we can say that negative a over 2 is equals to negative 5. So if you cross multiply, negative a is equals to negative 10. Hence, the value of a is simply equals to positive 10, like that. So that's how we find the value of a. Now, how can we find the radius? So now, to find the radius, we found the value of a. To find the radius r is given by the formula, the square root of g squared plus f squared plus b squared minus c. Okay, so what's our value of g? We saw that our value of g is negative 3. So negative 3 in brackets squared plus the value of f. The value of f is 10 over 2, which is 5. 5 squared minus c. Now, what is our c? Our c, you can see that our c is negative 15. So this will become a positive 15. So remember, the formula has a positive, but here we have a negative, hence the value of c is a negative 15. So r, in this case, will be equals to, so this will be 9 plus 25 plus 15. So the square root of, so 9 plus, that will be 49, I believe. This is 40, 49. Hence, the radius is 7 units. Just like that, that's how we find the radius. Okay, thank you very much. We're done with this question. So, given that matrix P is defined in terms of x, where x is not equal to 1, such that P is a 2 by 2 matrix, which is this one here. So, find the value of P times P transpose minus P transpose times P. So in this case, we can clearly see that P is multiplying with this transpose and then just like that. So let's see how it's going to proceed. So matrix P is the one that we have here, of course, which is 2, 1, x, 3. So the transpose of this matrix will be, so the row will become the column, that is 2x, 1, 3. We have that. So to find P transpose minus P transpose P, of course, this is my matrix multiplication. So P, we have 2, 1, x, 3. P transpose, we have 2x, 1, 3. Minus P transpose, 2x, 1, 3. And the P, which is 2, 1, x, 3. So let's do some matrix multiplication here. So row by column. So 2 times 2, we get a 2. Then x times x, we get x squared. 2 times 1, we get a 2. X times 3, we get 3x. 1 times 2, we get a 2. 3 times x, we get 3x. 1 times 1, that is 1. 3 times 3, that is 9. Minus, same thing. 2 times 2, row by column. 2 times 2, 4. 1 times 1, that is 1. 2 times x, 2x. 1 times 3, 3. X times 2, 2x. 3 times 1, 3. X times x, we have x squared, and 3 times 3, we have 9. So this is a 2 by 2 matrix as well as that one, so we can subtract the 2. So we're subtracting this minus this minus this, just the corresponding positions. So this is what we're going to get. 2 plus x squared minus, this is a 5, 5. Then 2 plus 3x minus this 2. So minus 2x minus 3. Remember that the negative will affect both of them. Then this minus this. So we have 2 plus 3x minus 2x minus 3. Then this is a 10, so that will be 10 minus x squared minus 9, something like that. So this will give us something is wrong. We're supposed to say this minus that, which is a 5. Okay, that's fine. So 2 times 2, we made the mistake with the first part here. It's supposed to be 4. Okay, so this is what it's supposed to be 4. So this will give us x squared minus 1. This expression here will give us x minus 1. This expression here will give us x minus 1. And this expression here is going to give us 1 minus x squared. Okay, so this is the value of pt minus ptp. That's what we're trying to find first. So we found it, it's this. Now we have to show that this is less than 0. In other words, we have to show that this is negative. Now, it's supposed to be negative given that you have found the determinant, because you can see that it's in the modulus, so we have to find the determinant. So how do we show that it's a negative? Since it's that we have the determinant here, we know that to find the determinant, we multiply the major diagonal, then we subtract the minor diagonal. So the major diagonal, what we have? We have this and this. So we're going to get x squared minus 1. This is multiplying with 1 minus x squared minus, open bracket, x minus 1, x minus 1. So this is these two minus these two, which is those two. Okay. So the next thing we're going to do now is we're going to factor out a negative so that we have the same expression here. This is what I mean. we factor out the negative. This will maintain as it is. We'll leave it as it is, like that. But this part will become x squared minus 1. Remember, this was positive, it becomes negative. This was negative, it becomes positive because we factored out negative. The reason why I've done this is because everywhere else will have x minus 1, x minus 1, x minus 1. But this one is one which was opposite, so I did that. So minus, open bracket, x minus 1. Okay, let's give it, let's leave it as it is for now. Let's leave it as it is for now. So let's apply the difference of two squares for these two. So negative, so that's x minus 1, x plus 1. Here we'll have x minus 1, x plus 1, difference of two squares, minus x minus 1, x minus 1, like that. Now let's put everything which is like terms together. So the negative is still there. Here we have x minus 1 squared. So this one and this one squared. Then x plus 1 squared. This one and this one. Minus x minus 1 squared. So we can see that x minus 1 squared is common. Please note that this is not the same as that. So let's factor it out. So we can also factor out the negative. It's fine. So negative x minus 1 has been factored out. What remains here? Positive x plus 1 squared. What remains here? Positive 1. Remember, we factored out this and this negative, which is that one. We factored it out. So we just remain with 1. Okay, so now we end here. Now, how do we conclude that this is negative? If you think of it, first of all, let's try to expand. Or maybe let's leave that. It's better this way. So this is a negative. We can say this is less than 0. How do we come to this conclusion? Because if you think of any number other than 1, if you think of any number that you can decide to put here, once you put that number here, this will become a positive because of the square. You put that number here, this will become a positive. So without this negative here, this will be a positive value, this will be a positive value. And since all these are positive values, because of this negative, all those positive values will change to a negative value. Meaning that regardless of what number you think of, you have a number which is less than 0. Let's take an example. Let's take negative 2. If we put negative 2 here, we'll have negative 2 minus 1 squared. Put negative 2 here, we'll have negative 2 plus 1 squared plus 1. So this will give us negative 3 squared, which is positive 9. Remember, we still have this negative outside. This will give us negative 1 squared, which is just 1 plus 1. So this will still give us a negative value. So this negative will allow whatever number you replace x with, except 1, whatever number you replace it with, you will always get a negative number, meaning that this whole expression is less than 0. So this is how we show it. So thank you very much. I hope it makes sense. Okay, so given this equation, how do we show that the derivative is given by this expression? So it's important to note that we're going to use implicit differentiation simply because in our curve, we have both y and x. So to understand implicit differentiation, for this part where we have x to the power 3, we're just going to differentiate x with respect to x. I don't know why we do it. But for this part where we have a term with y, we're going to differentiate with respect to y and multiply it with dy dx. Then for this part, we have x and y. We're going to consider them as two functions multiplying, and hence we shall use the product rule. So let's go ahead. So to start with, we have 3x, or x power 3, sorry. So x power 3, let me just write the whole thing, 2y cubed, this is equals to 3xy. So this is what we're going to do. The derivative of x cubed is simply 3x squared. The derivative of this expression with respect to y is 6y squared. Now, since we're differentiating with respect to y, we're going to multiply this with dy dx, of which we shall just use y prime in this case. On this other side, we have x and y multiplying. So like I said, for this side, we're going to use the product rule. So the product rule that we're going to be using is the first function, which is our u. Let's use, let's get 3x. Then v, let's get y. So what's the derivative here? U prime is simply 3. V prime is simply 1 multiplied by dy dx. Remember what I said? When you differentiate with respect to y, you always have to multiply that derivative with dy dx, or y prime in this case. So, according to the product rule, it's given by the formula uv prime plus vu prime. So let's do the substitutions. Our u is 3x. Our v prime is simply y prime, plus our v is y, and our u prime is 3. So if we simplify this, we are going to get 3x y prime, or let's just leave it as this, 3y. So this is what we get when we differentiate this part, which has x and y. So we use the product rule to obtain this expression. So here, the derivative of this part is simply 3x y prime plus 3y. Now, what we're going to do next is we're going to make dy dx the subject of the formula, or we're going to make y prime the subject of the formula. So we're going to do it in this way. This will become 6y squared y prime, this part that we have here. This expression also comes this side, so that will be minus 3x y prime. This is equals to 3y, this 3y here. The 3x squared also go to the other side, so I'll say minus 3x squared. Okay, from there, since we're making dy dx a subject of the formula, let's factor it out. So if we factor out dy dx, what do we get? We'll have 6y squared minus 3x. In brackets, we have factored out dy dx. This is equals to, what is common here? 3. So let's just factor it out. So 3 is common. What remains? Y minus x squared. Since we want dy dx, we're going to divide both sides by this expression. So y prime is equals to 3, open bracket, y minus x squared divided by this whole bracket, which is 6y squared minus 3x. Now, at this stage, what we can do is we can also factor out 3 here because it's common. So y prime, like I said, is the same as dy dx. So I can just write it like that. It's okay. This is equals to 3, open bracket, y minus x squared divided by, we factor out 3 in the denominator as well, so 3, open bracket, 2y squared minus x. Then the 3 can cancel out, meaning that, let's just do this a bit, meaning that this whole expression can just reduce to what we are supposed to find. So if the 3 cancels out, this will just result to y minus x squared divided by 2y squared minus x, which is that expression. So just like that, we have shown that dy dx is given by this expression. Okay. So given this function of y, how can we find the derivative? How can we find dy dx? So first of all, it's important to note that this is a fraction, so the two functions are dividing, meaning that we're going to use the quotient rule. But before we go into that, we need to get the top part and the bottom part. We differentiate them separately, and then we'll see how we break them. So the top part, or the numerator, in this case is u, is equals to x squared ln 2x. The bottom part, that is our v, which is e to the power x, open bracket, x squared plus 1. Okay, let's take the derivatives. So the derivative of this is, we're supposed to use the product rule. Now, it's important to note that to use the product rule, again, we have to consider two functions multiplying. So this is what I want to do. Let's apply the product rule in the process of trying to differentiate this whole function. So for these two, the first function, let's call it u again, so x squared. I'm using a different color to differentiate. V is ln to x. Then u prime, in this case, is 2x. V prime is, so how do we differentiate this? The derivative of this will simply be 1 over 2x. Okay. So the formula for the product rule is given by uv prime plus vu prime. So it's just a matter of substituting now, then we get the derivative for that particular expression. So if we do the substitutions, it means that the u prime, this u prime, let's just bring it here, this u prime, we're applying this formula, which is just substituting what we've got in here. So our u in this case is x squared. Our v prime is 1 over 2x. Our v is ln 2x. And our u prime is 2x. So 2x, like that. So if we try to this u prime, so u prime in this case will be equals to the x and the x here will cancel, leaving us with x over 2 plus 2x ln 2x. That's what we get. So we have u, now we have u prime. Okay, let's just demarcate. So for this guy, we're going to do the same as well. We're going to take the product rule. So small u, it will be e to the x, and v will be x squared plus 1, like that. Then u prime will be e to the x, v prime will be 2x. So the formula for the product rule is the same, which is u v prime plus v u prime. So let's take our v prime now. This guy, let's take our v prime. Let's bring it here. So v prime, in this case, will be equals to, substituting in the formula, we'll have u e to the x. V prime is 2x. V is x squared plus 1 multiplied by u prime, which is e to the x. So v prime, in this case, will be equals to 2x e to the x plus x squared plus 1 brackets e to the x. Okay. Now, I hope I'm not getting lost. What we need to find the derivative is this 1, 2, 3, and 4. This is what we need. Now, here's how we need it. Remember, we have to apply it in the quotient rule. What we've done so far is just the product rule. So applying it in the quotient rule, this is what will happen. The quotient rule is given by the formula dy dx is equals to vu prime plus uv prime divided by v squared, of which our v is this one here, our u prime is this one, our u is this one, and our v prime is this one, and divided by v squared. So let's apply our quotient rule here. So dy dx will be equals to, so what is our v? Our v is this one that we have here. So let's just do this. So v, we start with v, which is e to the x, open bracket, x squared plus 1. That is multiplying with u prime. U prime is this expression that we have here. So let's use this bracket and say x over 2 plus 2x ln 2x. We're supposed to subtract, not add, sorry. So minus, and from there we're going to say our u, which is that expression, which is x squared ln 2x. Then we say v prime is this one here. Let's put it in brackets as well, which is 2x e to the x plus x squared plus 1 e to the x, like that. And I can close the bracket. Okay, now everything is over v squared. So our v, remember our v is this guy here. So this will give us e to the x squared plus 1 in brackets squared. Okay, so now at this stage, we can see that we can factor out e to the x here. We have e to the x there. So we can factor it out. Then I would want it to cancel out with this e to the x that is down here. So let's see how that goes. So our dy dx will be equals to, so let's bring it here. So e to the x, we factor it out. We have x squared plus 1 in brackets. We have another bracket here, which is x over 2 plus 2x ln 2x, like that. So minus x squared ln 2x. Remember, we have e to the x here, e to the x here, so we can factor out, we can go that side. So what will remain with will be, put these in brackets, then open another bracket for this part here, which is 2x. Then for this part as well, which is plus x squared plus 1. Because remember, the e to the x has been factored out. Then close the bracket. In the denominator, we have e to the x, let's just do it like this, squared, then x squared plus 1 in brackets squared. So at this stage, we can see that one of these can cancel with that. So that we just simplify it like that. Then if we just leave it like that, it's fine, it doesn't matter. So our final expression, we can write it as dy dx is equals to, so what do we have here? We have x squared plus 1 brackets. We have another bracket here, which is x over 2, no need of expanding, plus 2x ln 2x, like that, minus what we have here, x squared ln 2x, open bracket, 2x plus x squared plus 1, like that. Then everything is over. Remember, one of these cancelled, so e to the x multiplied by x squared plus 1 squared. So we can leave it there, it's fine. That's our derivative. But even if you intend to expand, it's okay as well. All right. The straight line has Cartesian equation given in this form. So the question says, show that the point P with coordinates 16, 24, 28 lies on this line or equation L. So what we're going to do is, we're going to let every part of the equation be equals to lambda, for example. By that we mean this part, which is x minus 2, over 2, let it to be equals to lambda. The second part as well, same thing, which is y minus 3 over 3 is equals to lambda. And the third part, which is z minus 4 over 2 is equals to lambda. Okay. So now remember that the coordinates for P are 16, 24, and 18. So 16 is the x coordinate, of course. 24 is the y coordinate, and 18 is the z coordinate. So what I want to do is we need to find the value of lambda. And if we discover that the value of lambda is the same throughout, then it means that this point lies on the equation. So we're going to replace x, y, and z with these coordinates for P. And then we see how we can find the value of lambda. So here where there's x, we replace with 16. So that will be 16 minus 2 over 2. This is equal to lambda, of course. Same thing here where there's 18, we'll replace it with 24 minus 3 over 3. This is lambda. Same thing here, 18 minus 4 over 2. This is also lambda. So 16 minus 2, which is 14, divided by 2, which is 7. So the value of lambda here is 7. Same thing here, 24 minus 3 is 21. 21 divided by 3 is 7. 18 minus 4, that's 14. 14 divided by 2, that is 7. Okay. So since all three coordinates give the same value of lambda, this shows that the point P lies on the given Cartesian equation. So this is how you show that this particular point lies on the equation. So we can conclude by saying, since all three coordinates give the same value of lambda, then this shows that P lies, so we can say point P lies on the equation, Cartesian equation L. That's it. So the planes pi 1 and pi 2 have respective Cartesian equations, which are given by these two. Find the acute angle between the two equations. Okay, so this is what I want to do. We're first going to write them by writing down their coefficients only. Then we'll find the dot product, and then we'll also find their magnitude. So starting with this equation that we have here, this is pi 1, of course. So we can say pi 1 will be equals to, so let's get the coefficients of x, y, and z, which are 1, coefficient of y is 2, coefficient of z is -1. Right. Then for the second one, which is pi 2, this will be given by 1, comma, 3, comma, 1. Okay. So the next thing we need to do now is we need to find the dot product between these two vectors. So the dot product, like this, pi 2 will be given by, so 1 times 1, that will give us 1, plus 2 times 3, that will give us 6, plus -1 times 1 should give us -1. So the dot product of the two is simply equals to +6. That's the 1 and the 1 will cancel. So that's the dot product. Now let's find the individual magnitudes. So pi 1, the magnitude of pi 1 is given by the square root of the square of everything that we have here. That is 1 squared plus 2 squared plus -1 squared. Okay, so what we get? So pi 1, the magnitude, this will give us 1. 1 plus 4 plus 1. So the magnitude of pi 1 is simply equals to the root of 6. Simple as that. Let's find the magnitude of the other one. Let's just put it here. So pi 2 magnitude, this will be given by the square root of square of everything here. So that is 1 squared, 3 squared, 1 squared. So pi 2 magnitude is equals to the square root of 1 plus 9 plus 1. So this will simply be equals to the magnitude of, rather, the square root of 11. So there we have it. So now that we have these two, how do we find the angle between them? So the angle between them is given by the formula. Since we're using the dot product, then we're going to say theta. is equals to cos inverse of open bracket. So the dot product divided by their magnitudes. So that's pi 1, this is pi 2. So that's how it's found. Okay, let's do this. So theta in this case will be equals to the cos inverse. So the dot product is divided by 6. So we can just say 6 divided by the product of the magnitudes. So the first magnitude is root 6, the other one is root 11. So theta is equals to the cos inverse of 6 divided by root 66. If you multiply these two, we just get root 66. So if we find the cos inverse of this, we'll see that the value of theta in this case will be equals to 42.4 degrees. So this is the acute angle between the two. Okay.